So I thought a great place just to start this conversation would simply be, what is controlled environment agriculture?
Right. So controlled environment agriculture, you're not supposed to define something by its name, but the name sort of defines it, right? But it's the environmental conditions important for plant growth. We are actually controlling those rather than being, subject to outdoor weather or being limited to your particular climate. We actually produce our crops, and we're going to focus on the plant side of controlled environment agriculture today. We actually produce our crops in structures such as greenhouses or indoor vertical farms that then have unique systems in them that basically allow us to grow indoors where we have at least a moderate, if not a high level of control over the environmental parameters inside there that are important for that plant growth.
Yeah, that makes a lot of sense to me, but it also sounds pretty familiar. I feel like I've seen greenhouses for most of my life. How far does that go back?
So yeah, so people are very familiar with greenhouses. We've seen them used for ornamental plant production. You may see large greenhouse complexes and not necessarily even know what's growing in those structures, but they've become everyday and we don't tend to think about those. But some form of controlled environment agriculture goes back to at least Roman times. So we have literally writings from Pliny the Elder. I've always wanted to say that because I watch a lot of history and you hear people read writings, right, of Pliny the Elder, but who literally wrote about structures called specularia that were used to grow cucumbers, either in extended or out of season. And those were very rudimentary structures that were sort of brick or stone with a selenite, sort of think about like giant sheets of mica. It's not mica, but a transparent material on top, manure piled inside to generate heat from decomposition. And then they could grow things like cucumbers when they couldn't normally grow them out. So very, very rudimentary, but all the way to Roman times, people have been, designing controlled environments. If you move into the 1600s, as we developed plate glass, which, going from rolled glass and early rudimentary glass to plate glass, floating glass, things, that was a huge technological boom for us, if nothing else than windows, right? And then everything else glass is used for. But in CEA, when plate glass, for example, became common, we then had what we refer to as orangeries, which became sort of the rage in Europe and fashion in Europe. And an orangery typically reserved for wealthier individuals. You'll see it in Europe in old estates, would typically be, for example, a large ornate building where a south facing wall is largely giant windows, right? Possibly on the roof. And people would get pomegranates, bananas, citrus fruits planted in giant pots, right? Sitting in front of those windows. That would allow out of season production of a lot of those things. And oranges and citrus were very popular, right? So that's where the name orangery came from. They again were primitive to what we do today. We had no supplemental lighting. We had limited temperature control. We didn't have advanced heating systems. But I think the point is, we all think controlled environment agriculture is this new thing, but we can really trace it all the way back to Roman times and watch it develop as various technologies have developed. And the CEA industry, controlled environment ag, have adopted those and used those to sort of advance the particular field.
What are some of the latest technologies that are driving or empowering this most recent kind of, I don't know if it's a boom or if it's just an increased interest in controlled environment agriculture?
Yeah, I think a little bit of both. There's an increased interest and increased visibility, and you could say a boom for various things. But there have been some, again, technology has driven the change in CEA, right? And most recently, the thing that you would probably point to right now is that we made great advances in LED lighting systems. It became very efficient compared to what we had. The reason that was important was, as we talked a little bit earlier, we're all familiar with greenhouse production in CEA, but that made the use of and the development of indoor vertical farms possible. And what I mean by that, rather than, greenhouses having a transparent glazing, right, that lets light in, indoor vertical farms tend to be built in things like warehouse. You'd go by and it would look like a warehouse to you, right, or a big shipping facility, or it could be renovated schools or renovated structures, but they typically do not have building materials that allow light to come in. So we have to supply 100% of the light inside. And as a result, with our old lighting technologies, of course, those lighting systems were so inefficient. So much of the energy went to heat, you just couldn't do it. So LEDs have been changing the game on that and allowing indoor vertical farms where we grow very high, up into 30 some feet high on racks and whatnot, to become something feasible now. There's a lot of technologies always coming. LED, we're now making them more and more efficient, but it's already honestly, it's kind of past in CEA, right? There's a lot of other things we're looking at, the next technology and the next technology. So that's one of my favorite places to be is, what's the next thing?
Yeah. Well, what is the next thing?
I think there's a number of candidates, right? We don't know, right? So we see technology develop in another field, and what we do is take those technologies and how can we adapt them? And a lot of times those technologies may not work. A lot of times those technologies might be really cool, but the cost benefit, right, the economics don't really bring you anything. But that's kind of what we do in the university and in the centers. We're always working with companies and others in developing those. So let me give you an example of one of those that's out on more cutting edge for CEA. Let's go to the greenhouse side of things. And I mentioned all the way back to using, selenite, to Roman times. And then we develop plate glass it gives us, options. And then of course, improvements over time to glass allowed us, to develop glass greenhouses and whatnot. And that was a big deal. We then went to things like polycarbonate and acrylic panels, which a lot of those that are the modern polycarbonate and acrylic types of panels for glazing coverings of greenhouses get pretty close to what the light level that glass will allow in, but they're much, much more insulated for energy conservation. They are also very, very lightweight, which allowed us to reduce the amount of structure that we had to have, right? It's not so heavy, and that's kind of where we're now. Now, some of the fascinating research that's going on is using, the whole agricultural photovoltaics industry that's out there with combining solar with agriculture in various ways. It's also going on in CEA. So there are folks that are looking at special types of panels. So they would be the covering of the greenhouse, right? And they allow a certain percentage of the light to enter the greenhouse that the plants can then capture and use for photosynthesis. But some of that light doesn't enter, it's captured by the panel. And the panel uses that proportion of light to make electricity to run the greenhouse. So, the idea is because most of the time in a greenhouse, a lot of the season, we don't need 100% of the light. So imagine outdoors in the summer here, you will often go by greenhouses and they have shade cloths up, they spray paint white dilute latex paint. Much of the year, we may actually be getting more light than we need. So the theory is we'll let in a certain percentage of that light for the plants. The other we'll use to generate our own energy to run the greenhouse. So that's kind of looking ahead where people are trying to go in the glazing or the covering on greenhouses, and that's just an example of that cutting edge out.
Yeah, that sounds like it would definitely be in the running for possibly the next big thing. I'm curious too, are we getting better at maybe learning what types of light or how much light we need? Does that impact how plants grow? I don't know anything about how much a plant needs to grow light wise. You can go out in our backyard or my garden, and see anything you see growing is my wife is responsible for that. All the dead things I did. So
Well, we'll work on you, but it's dangerous to ask, plant scientists about plants because how long do you have, right? But what people don't realize, we'll make it, a little shorter answer. It's not just light. We will train students like in classes. There are three, if you want to say, aspects of light that absolutely impact plants. Okay. One is what we call photo period, and that's the length of the day. You know this, our days are getting shorter, right? We have shorter days in the winter. They start getting longer in the spring. They're long in the summer. They start shortening again. in the fall. And photo period has a lot of impacts on plants. So, how long that light period is affects a lot of things with plants. The second thing would be we're just going to use the lay term intensity, right? How bright is that light? How much light is coming in? And that is the photons or the energy, if you want to say it that way in lay terms, for the plant to run photosynthesis. So the amount of light, the brightness of the light coming to provide the energy. But as you alluded to, it's not just light, it's the quality of the light, right? We all know looking at a rainbow, there's a spectrum in there. When you have a prism or rainbow that shows us there's red light, blue light, green, right? And plants use certain wavelengths of light more efficiently for photosynthesis, but also certain wavelengths of light affect how plants grow differently independent of photosynthesis. And just a real easy example to understand, if I get blue LEDs, let's say I enrich the environment in blue light, most plants respond to that by getting darker, short green, shorter, spottier, right? And they become more dwarf, more red, they'll stretch more. If I put in far red light, they'll really stretch. So yeah, so when we are working in a controlled environment with lighting, especially if you do indoor vertical farms where 100% of that light's being supplied, it's not just how much light, the intensity, it's also the duration that those lights are on, but it's also the quality. We call that the emission spectrum that we're supplying. Do we want red and blue light pretty balanced? Do we want red and blue balance with a little bit of far red? And that mixture, right? That recipe of the spectrum, there's a whole science behind that companies that sell lights are involved in.
Wow. So it sounds like I like the that word recipe that you use there because it sounds like that you are trying to, with this new technology, with these new lights, perfect the recipe to help the plant grow the way that you want it to.
The way we design fertilizer recipes to get them just the right nutrient, you know, solution in there, it's a little bit like that with light to get just the right lighting recipe right.
Yeah, that's awesome. That makes a lot of sense to me. Well, what are some of the challenges when it comes to this technology and doing controlled environment agriculture?
Some of the challenges I think that we're always looking to be more efficient. As you can imagine, it's, when you build a controlled environment facility, you have high capital costs, right? You've had to build this facility, put in these systems and whatnot. So you've got to recapture that somewhere. And we recapture that different ways. We can certainly typically, and this all is predicated on doing things right. We can grow typically year round. We can produce more product, say per square foot or whatever, whichever measurement you want, than you can in a field scenario. We often can use less water, less fertilizer, less pesticides if we use pesticides at all. But again, we tend to have higher capital costs to get started. So when we go in and we start operating, we have to really look at our operating costs versus our productivity. So efficiency is really, really critical to make it economically work out. And you'll see a lot of work going into maximizing production, reducing inputs, and getting the economics to work out there. So the challenge is always looking at the bottom.
Okay. That's awesome. And it's so fascinating that it kind of comes back to that. But it makes sense because at the end of the day, I don't know if there's any farmer I've ever met that wasn't what they were worried about was the bottom line, right?
Exactly. And, it's good that you brought that up because in the industry, folks like myself, and we're getting ready to have a meeting in Danville that we host, and a lot of industry people coming. There is a lot of discussion that, yes, technology drives this industry, right? We are high tech. Technology can be great, but at the end of the day, it's farming. And that we really have to still think, you have to think both as a technology person and a farmer. You're growing crops. You need to grow the quality, good quality in the crop, that your buyer wants and the products they want. But at the end of the day, if you're going to be sustainable economically, you have to be able to produce that product and sell it at a higher price than what it costs you to produce it. So a lot of people are talking about rediscovering that we are agriculture first, right? We are farming first, and all technologies that we use have to basically, at a minimum, pay for themselves, right? You can't just because a technology is sexy or a technology, does this or that. It's got to always somehow to go back to the bottom line. And you're hearing this mantra repeated in this industry. We have to remember that we're farming and think that way. So you're absolutely right.
Yeah.
I work a lot with farmers of all kinds, and they're just some of the most intelligent, smartest, wisest economists you'll ever meet.
Yeah, I was gonna say too, I feel like the farmers that I met, and full disclosure, some of my family, my grandparents were farmers. I feel like they were some of the most technologically savvy people. Maybe not in the same way, like they didn't want to play Game Boy with me, but they knew like how to take something that I wouldn't see value in and do things with it and make it work for them.
Right. I think they've gotta know their crops. They've gotta know their or animals if they're doing that. They've really gotta know a lot about that. They've gotta know the technologies, and they've gotta be really good business people. And I think every farmer I've ever known that was successful is just talk to them, and you'll find out they're extremely smart business people.
Absolutely. Well, I'm curious, as controlled environment agriculture as it might be scaled up, what are the benefits to somebody like me, just the average consumer? How would I see that impact my life?
Yes, so I think, first of all, I would tell you it's already scaled up.
So maybe how is it impacting me and I just don't know it?
Right, well, that's what I was gonna, yeah, exactly. So, we're adding capacity, certainly, but I guess I changed that word for you because scaling up, to me, a lot of times I feel like we're trying to go from small to large and see if it works, right? We already have operations that are very large, even in this state, and still growing, but today even, it's impacting your life. So I'll tell you, when you go grocery shopping next time, look at how many produce products, if you pay attention to the label, say greenhouse grown or hothouse grown or indoor grown. That number is growing a lot. I grocery shop and I notice, lots of tomatoes you will see now labeled on their packaging that they're coming out of some type of controlled environment facility. I'm a big fan. I don't know if you love the little baby cucumbers and things, that you see in the packages. I love those. They're largely, go look, you'll see they're largely coming out of greenhouse locations. Look at all the baby leaf greens that you're seeing, right? And look at how many of them will be labeled as greenhouse grown. Some of them actually are and not labeled. So you're being impacted in the produce department much more by CEA produced produce than you might realize if you're not really reading labels. So I would say you are now. Going forward in the future as the industry scales even gets larger and larger and consumes more, I think it'll depend a little bit on how things go because a lot of focus is going into novel crops, higher quality produce. So there's a lot of discussion about producing strawberries that are super sweet, for example. Can we produce those cherry tomatoes that are super sweet? Can we take additional crops that have been traditionally field crops? Can they be adapted? So you may start seeing sort of some of the same types of produce you have in the produce department, marketed in a different way based on quality parameters. You may start seeing additional crops that maybe aren't currently grown in certain seasons or grown in CEA being moved into CEA and those crops being available, more year round rather than just seasonally. So yeah, take a peek at some when you go buy those greens and those tomatoes and those cucumbers, take a peek and see how many are labeled as, greenhouse grown, hothouse grown, indoor grown.
Yeah, I definitely will, especially the cucumbers because that was one of the most historic vegetable that they were grown in Rome, right?
Cucumbers go all the way back to Tiberius, I think it was, who wanted cucumbers and they would grow cucumbers. So yeah, and again, you start seeing sort of a change in the product, right? You can see the traditional cucumber that's a little bit larger, right, and may have seeds, and you'll see CEA producers starting to use other types of varieties, other types of melons, for example, or things, trying to give the consumer a little bit of a different product. So when you go out shopping, you'll see the little baby cucumbers, right? And they're seedless and they're thin skinned, and you'll see them in a bag or a clamshell or something, and growing crops that are a little bit different to differentiate the product.